Hello. All right, so if you can turn to page 4 it's the Unit 4 packet, but it's the exponents portion of it. If you could turn to page 4 of that. Over the weekend, you guys were supposed to watch an ed puzzle that introduced fractional exponents. And I know the video talked about when you have a fractional exponent, okay, the numerator represents the power and the denominator represents the root. So for example, I'm just going to take a look at number 1. 16 to the 1/4 power. Okay, so the numerator represents the power and the denominator represents the root. So we could write this as the 4th root of 16 to the 1st power. So that's what we did here, the 4th root of 16 to the 1st power. And then we just figured out that the 4th root of 16 was 2, right? Because 2 is the number that we multiply together by itself 4 times to give us 16. And then 2 to the 1st, it equals 2. All right, so feel free to look back at some of the examples that the ed puzzle covered. It covered numbers 1 through 4 as well as 9. And then what I'd like you to do is I'd like you to try the evens on this page. So it looks like the evens that we haven't done were numbers 6, 8, and 10. So I'd like you to try numbers 6, 8, and 10 on your own. So hit pause and try those 3 problems out. All right, so when we have a fractional exponent or a rational exponent, again, the numerator represents the power and the denominator represents the root. That's why we say power over root. Okay, so we can rewrite this as the 4th root of 81 to the 3rd power. All right, so let's do that. We're going to rewrite this as the 4th root of 81 to the 3rd power. Now, you can either put the 3 right here on the 81, or you can take that 3 and you can put it on the outside of the radical right here. Now, the reason I recommend, if you're going to evaluate what this is equal to, the reason I recommend putting it on the outside of the radical is because if you put it on the inside, you would first have to figure out what 81 to the 3rd power is, which is a huge number. And then you have to take the 4th root of that huge number. I think it's always easier to, take the root of a smaller number and then cube it. Now, some of you may have to use your calculator for this anyway. I'm not really sure. But if we want to figure out what the 4th root of 81 is, you're just figuring out what number can I multiply by itself 4 times to give me 81. All right, well, basically, 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So the 4th root of 81 is 3. Okay, if you have to use your calculator, what you do is, this is going to be weird, but you hit math. Okay, and if you look at the screen, do you see how it says, the 5th one down says the xth root? Well, we're going to choose choice 5. And on my calculator here, I have to actually scroll back to where it says answer. So I'm going to use my left arrow key and scroll back to where it says answer. And I'm going to replace that with a 4. So we now have the 4th root. And then I'm going to use my arrow key to scroll under that radical and plug in 81. And when I hit enter, you can see it's equal to 3. So if you can't do that in your head, you can always do that in your calculator. Okay, you hit math and go to the 5th option down. Okay, so then from here, since the 4th root of 81 is equal to 3, we're going to have 3, and then we still have this power in here, 3 to the 3rd power. So 3 to the 3rd power, again, if you have to use your calculator, go for it, but that one should be okay in your head, right? It just means 3 times 3 times 3. So 3 times 3 is 9, and 9 times 3 is 27. So there you go. And if you want to check, you can always plug in your calculator 81 to the 3/4 power, and it'll give you 27. All right, so let's take a look at number 8. Now, number 8 has a negative exponent. Remember, if you have a negative exponent, first we want to do is we want to get rid of that. So I'm going to make this into a fraction, and to make an exponent positive, we move it to the other side of the fraction bar. So I'm going to take this 32 to the negative 2/5, and when I move it down to the denominator, it becomes 32 to the positive 2/5. Okay, and then I need a placeholder on the top, so I'm going to put a 1 up there. All right, so this gives us 1 over. So remember, power over root. So that means we have the 5th root of 32 to the 2nd power. So the 5th root of 32 to the 2nd power. Okay, so that's going to leave us with 1 over. All right, so the 5th root of 32? Well, again, you can either figure that out in your head. What number can I multiply by itself 5 times to give me 32? Well, the answer is 2. And if you have trouble doing that in your head, you could always plug in your calculator the 5th root of 32, and it'll give you the answer. So that's 2. And then don't forget about this square that we have up here. So let's put that on the 2. And since 2 squared is 4, we get 1 over 4. Okay, and then finally number 10. Now number 10, if we go back to our work from number 9, remember, if you have a negative exponent, I mean, technically you could distribute this onto the 9 and then onto the 16, right? And then to make our exponent positive, we would have to move the 16 up and the 9 down, and the exponent would become positive. But the shortcut way is, if you have a negative exponent on a fraction, didn't we just flip this fraction upside down and make the exponent positive, right? So I'm going to do the same thing here. I'm going to flip this fraction upside down. And when I do, my exponent becomes positive. Please don't flip the exponent though, okay? It becomes positive. All right, so now this power is being raised to both of the numerator and the denominator. Now, again, if we say power over root, okay, this would be the cubed root of, I'm going to start with the numerator, the cubed root of 27 to the second power. So the cubed root of 27 to the second power. Okay, and same thing with the denominator. If we take this 2/3 and make it an exponent on the 8, it's going to be the cube root of 8 to the second power. So the cube root of 8 to the second power. Okay, so the cubed root of 27 is 3. Okay, because 3 times 3 times 3 is 27. So that'll give us 3 squared over. And then the cubed root of 8 is 2, because 2 times 2 times 2 is 8. So that's 2 squared. All right, and then 3 squared is equal to 9, and 2 squared is equal to 4. So 9/4 is our answer. Okay, so if you turn to the next page, we're going to continue the trend with just doing the even examples, okay? If we do the evens, it gives us a good variety of examples. We don't have to do them all. So the directions here say to write each expression using a radical, okay? So there's nothing to evaluate. You're just rewriting these using a radical. So let me just pick an odd example to do with you, and then you guys, after we go over that, can hit pause and try out the evens on your own. Okay, you know what, let me try out this one, number 13. So if we take a look at number 13, it says x to the negative 2/5 power. All right, so the first thing we want to do is, I mean, there's a negative exponent, so we don't want to have a negative exponent. So I'll make that a positive exponent, right, by putting this over 1 and moving this term to the denominator of the fraction. So when I do, it becomes x to the positive 2/5. And then we put the 1 as a placeholder in the numerator. Okay, so that's going to leave me with 1 over, and then when we do, since we know it's power over root, okay, it's the 5th root of x to the second power. So the 5th root of x. Now, you can put the square on the outside of the radical, or if you want, you could also put it on the inside. You can make that x squared. That's up to you, whether you put it under here or up there. Because we're not dealing with actual value numbers here, right? We're dealing with a variable. We're not even going to evaluate this. So you can leave it there, and that's perfect. If you prefer to write it on the outside of the radical like that, that's fine as well. Okay, either one is good. All right, so you guys try out the evens on this page, and then you can hit play and see how you did. Okay, so number 12, I mean, this one's quick. We just have to rewrite it using power over root. We're going to write it in radical form. So this would be the 7th root of x to the 3rd power. Okay, the 7th root of x to the 3rd power. And you can put the 3 on the outside of the radical, or if you prefer, you can put it right on the x. Okay, either one of these two answers is acceptable. All right, if we take a look at number 14, now this has a negative exponent, so we first want to get rid of the negative exponent. So if we move this up to the numerator of the fraction, the exponent becomes positive. Now, I mean, you could put this over 1, but technically you don't have to, because isn't anything over 1 itself? So I think in the next step, I'm going to just get rid of the 1 in the denominator. All right, so I'm going to rewrite this using power over root. So the 6th root of b to the 5th power. And again, you could put the 5 on under the radical or on the outside. It's up to you. And I'm not going to put it over 1 because anything divided by 1 is itself. So, okay, either one of those is fine. All right, number 16. Okay, so number 16, you had to apply your exponent rules first. Remember, if you're multiplying two terms with the same base, you have to add these exponents. I'm going to add them off to the side. Okay, so if I want to add negative 7/2 plus, I'm going to make that 2 over 1. I first have to find a common denominator, right? So the common denominator would be 2. The first fraction already has a denominator of 2, so let's multiply the second fraction by 2 over 2, and then that'll also have a denominator of 2. Okay, so we have negative 7 over 2 plus, this is really 4 over 2. So negative 7 over 2 plus 4 over 2. All right, well, negative 7 plus 4 is negative 3. So you basically add the tops and you keep the bottom. It gives you negative 3/2. Okay, so let's come back over here. So we could rewrite this as a to the negative 3/2 power. So since we have a negative exponent, we want to make that into a fraction. And we want to take this term and move it to the other side of the fraction bar. So we're going to move that to the denominator. So when we move that to the denominator, it becomes a to the 3/2. Now, since we don't have anything left in the numerator, you do have to put a 1 there as a placeholder, okay? Because I know when it's in the denominator, you don't need it because anything divided by 1 is itself. But when it's in the numerator, 1 divided by a term or a number is different than, just that number without the 1 on top. You need to have it in the numerator. All right, so anyway, I'm just going to take this and rewrite it using power over root. So the square root of a to the 3rd power. Now, when we write the square root looks like this. You don't actually have to write the little 2 in there. I mean, if you want to write the 2 in there for the square root, you can. But normally we don't write it. The square root is just, a radical where we don't even put a number there. So we have the square root of a to the 3rd power. Okay, and that is the answer. All right, number 18. Again, we have to apply our exponent rules. So when we do, we have a power being raised to another power. So we have to multiply these. Now, I know what a lot of people like to do, and this is not correct. They're thinking when they multiply 3/5 times negative 2, they do 3 times negative 2 and 5 times negative 2. But be careful. This negative 2, if you make it into a fraction, it's actually negative 2 over 1. So when we multiply the exponents, we're going to have m to the, so we're doing 3 times negative 2, which is negative 6, and then 5 times 1, which is 5. Okay, so if we want to make this exponent positive, we're going to move it up to the numerator. And when you do, it becomes m to the positive 6/5 over 1, okay? But you don't have to put it over 1 because anything divided by 1 is itself. All right, so now if we want to write this using a radical, we just, again, you're probably sick of me saying power over root. But, okay, so this would be the 5th root of m to the 6th power. So the 5th root of m, and again, you could put the 6 up here, you could put it right on the m, wherever you want, but that's the answer for number 18. All right, so this is the last page we're going to cover today. If you flip to page 6, actually, that's not true. The lab classes and the regular classes are going to cover page 6, and the honors class, in addition, is going to cover page 7, okay? So I'd like you to try them on your own, and then when you're done, you can hit play and see how you did. Now, I just want to point out, on this video, I am going to go over page 6, but the honors class, you're going to go to page 7, try them on your own, and then you could look at the answer key that is on Google Classroom. Under Unit 4 handouts, you're going to go to answer key and look on there. Sorry, one other thing I wanted to say before you get started. Number 20 says to explain. When it says explain, it means you actually have to explain in words. Okay, if it says justify your answer, that's when you could show work. But number 20 says to explain, and yeah, number 21 also says to explain. So you have to explain in words whatever they're asking you to show there. Okay, so number 19, we've been doing this on the previous page a lot. When you have a fractional exponent, although I have to say that's a pretty bad looking exponent. It should be a little bit higher. It almost looks like we're taking 3b and multiplying it by 2d. Make sure your exponent goes higher than, it shows in this example. But we're going to do power over root. So this would be the d root of 3b to the second power. So here we go, right here. The d root of 3b to the second power. So letter D is the answer for number 19. Okay, now in number 20, like I said, it says explain, so you do have to put it in words. If it's easier for you to first do it by hand and then explain in words, you can totally do that. So let's just talk about that. In order to express this as an integer answer, all right, we first would use power over root to rewrite this. So we could first rewrite this as the cube root of -8 to the fourth power. I'm going to put the fourth up here. I think it's going to be easier. When you're dealing with numbers, I always feel like it's easier to put the exponent up here, because then you're taking the cube root of a smaller number. All right, so the cube root of -8 would be -2, right? Because -2 times -2 times -2 is -8. So this would be equal to -2 to the fourth power. And then -2 to the fourth power, -2 times itself, right, 4 times, is equal to 16. Okay, now what we have to do is we have to explain in words how we did this. Okay, so I just wrote each step next to it. So the first thing we did was using power over root, -8 to the 4/3 can be rewritten as the cube root of -8 to the 4th. So that was the first thing we did. I'm just literally putting in words what we did. Then here, the cubed root of -8 is -2, right? So I just wrote out the cube root of -8 equals -2. That's all we did. We just took the cube root of -8 and wrote it as -2. And then to go from here to here, we said -2 raised to the 4th power equals 16. So you literally just have to put down in words what you did to go from one step to the next. Okay, so I'm going to do the same thing for 21. I'm going to first do it by hand, and then I'm going to put into words what we did. Okay, so, the first thing we would do here is, if we have a power raised to another power, we would multiply those, right? So let me put this 2 over 1. And we're going to rewrite this as 3 to the, 1 times 2 is 2. And 5 times 1 is 5. So it's 3 to the 2/5 power. Okay, now, using power over root, we can rewrite this as the 5th root of 3 to the 2nd power. So the 5th root of 3. Now be careful. If you put the 2 out here, it's actually not going to match up with how they want you to write it. Don't they want you to write it as the 5th root of 9? And isn't 3 squared equal to 9? So instead of putting the square out here, let's get rid of that. We have to put the square on the 3. That was tricky. Okay, because we want our work to match up with that. And then since 3 squared equals 9, we can rewrite that as the 5th root of 9. And that's what they wanted it to look like in the end. All right, so now I'm just going to attach words to this. Okay, so first thing we did was, when raising a power to another power, we multiply these, right? So when raising a power to another power, multiply exponents. That's exactly what we did. Okay, then we did power over root, right? We rewrote this as the 5th root of 3 squared. So using power over root, 3 to the 2/5 can be rewritten as the 5th root of 3 squared. And then didn't we just take 3 squared and rewrite it as 9? So 3 squared equals 9, and that's it. You just have to put it into words. All right, so lab and regular, you guys are done. The honors, the accelerated, you guys are going to do the next page as well. And then you're going to check with the answer key on Google Classroom.